Hello, my name is Judy and Patton. In this video, I'll be discussing about multiplication rule of probability.
But before we go on, let's unlock the word probability first. When we say probability, this concerns a numerical description of how likely an event is to occur or how likely it is that a proposition is true. To calculate probabilities involving one event and another event occurring, we can use multiplication rule of probability. First, let's talk about independent event. One event outcomes has no effect on the other event outcomes, or two events are independent if they do not affect one another. For example, rolling a 5 and then rolling a 3 with a normal 6-sided die. These events are independent because rolling a 5 does not change the probability of rolling a 3. It is still 1 out of 6. The same is true the way around. Rolling a 3 does not change the probability of rolling a 5. The multiplication rule of probability and independent events says that the probability of two events, A and B happening together, is the probability of events A multiplied by the probability of event B. So to answer the example that was given earlier, using the multiplication rule for independent events, so the probability of getting a 3 and a 5 is the probability of 3, which is 1 out of 6, times the probability of getting a 5, which is 1 out of 6. So the probability of getting both 3 and then a 5 is 1 out of 36. Let's have another example. If two coins are flipped, what is the probability that they both land heads up? First, we will name some of the events. We will say that A is the event of the first coin lands heads up, and B is the event that the second coin lands heads up. And we will find the probability that they both land heads up, which is the probability of A and B. As we solve this problem, we know that the probability of the first coin lands heads up is 1/2, and the probability that the second coin lands heads up is also a 1/2. So to find the probability that both A and B occur, we are just going to multiply their individual probabilities. The probability of A times the probability of B, which is 1/2 times 1/2 equals 1/4. And this works because these two events are independent, which means that either one of them occurring doesn't affect of the probability of the other one occurring. But what if the second event's probability is based on the outcome of the first event? In this case, it is dependent event. Two events are dependent if they do affect one another. In dependent event, the probability of A and B, wherein the probability of A multiplied by the probability of B given that event A happened. For example, suppose we have a box that contains 10 marbles. 7 of the marbles are green and 3 of the marbles are blue. Based on this, we know that the probability of throwing one green marble is 7/10, and the probability of throwing one blue marble is 3/10, or 0.3. If we randomly select 2 marbles from this box, what is the probability of throwing a green marble then a blue marble without replacement? And the term without replacement means that we are drawing a marble without putting it back into the box. This means that the probability changes after every draw. So the first event changes the probability of the second event. In this case, we will use the formula for the dependent event. For the first event, there are 10 marbles in a box, and since we have a total of 7 green marbles, the probability of throwing one green marble is 7/10, or 0.7. For the second event, the probability of throwing a blue marble is not 3/10, since there are a total of 9 marbles left in a box, with a total of 3 blue marbles remaining. So the probability of throwing a blue marble is now 3/9, or 0.33. As you can see, the probability of drawing a blue marble has changed. Now, to solve this problem, we multiply their probabilities together. 7 over 10 times 3 over 9, and we get 7 over 30 or 0.233. Let's have similar example. If there are 6 black pens and 8 blue pens in a jar, if you take a pen without looking and then take another pen without replacing the first, what is the probability that you will get 2 black pens? So to solve this problem, we will name the 2 events. The first event is that if we are going to take the first black pen, we got a probability of 6 over 14 or 3 over 7. And then if we take another pen without replacing the first, the probability will change into 5 over 13 since there are 13 pens left and 5 are black. Therefore, to get the probability of this event, again, we will just multiply their probabilities together. So 3 over 7 times 5 over 13, we get 15 over 91 or 0.16. For short recap, don't be confusing on identifying independent events and dependent events. Just always remember that independent events, the outcome of one event does not affect the outcome of the other event. If events A and B are independent, the probability of A and B occurring is equal to the probability of A times the probability of B. While the dependent events, the outcome of one event does influence the outcome of the other event. This is commonly seen when drawing an item or not retort. If events A and B are dependent, the probability of A and B occurring is equal to the probability of A times the probability of B after event A has occurred. So if 2 events happening together, you can use multiplication rule of probability. Just make sure to identify the events if it is dependent or independent and do your calculation accurately.